Okay. Seems like we're streaming. Perfect. Okay. Everything's all set up by the looks of things. Perfect. So, I want to develop a programming language, something super simple, nothing crazy. Just probably a little stack-based concatenative thing. And I don't really want to use any backends. No LLVM, no CraneLift, no QBE. I don't even want to use an assembler, so no FASM or anything like that. So what we're going to do is do all of it ourselves. We're going to generate the elf executable. We're going to generate the machine code and everything from scratch. It'd be pretty simple to do, methinks. It might be a bit more convoluted, really, rather than complex. What I'm thinking. Let's just create a thing. Let's get this boilerplate out of the way. Okay. I suppose I could do about that or something. Doesn't really line up nicely. Though I could do that just to see when stuff comes in. We'll see. We'll see what this layout. Let's just get a. Just build it statically. It should build statically anyway, but why not? We'll do it. There we go. We're building our executable. Let's ever think about this language. So let's say we have a test.fab. What are we expecting? Probably some kind of integers, so say 2022. It'd be nice if we could add them together. So let's convert this into what we would expect sort of the machine code to look like. So let's just have some kind of test.s. We're not going to be using any assembly backend, as I said, but let's imagine what it's looking like. I don't need to worry about this. So for this, we're probably going to have some kind of, this is stack based, pushing to the stack, popping from the stack for things, and we're not going to do any optimizations. Obviously, we could do this at compile time if we wanted to, but we're not going to worry about that. So let's say we move some stuff into a temporary register, so we'll move 20 into it, then we'll push racks. Move 22, push racks again. Then we want to add these two things together. So we need to pop into RSI, pop into RDI, then we can add them together, and then we can push the result of that add back into the stack. But if we're doing this, we need to properly exit our application. You don't just do a return to return back to the, like, sorry, say we're finished executing. What we need to do is use the exit syscall, at least on Linux, and well, with Unix in general, really. So a syscall has its, oh, I can't type, has the syscall number come in via racks normally. And it'll be 60 in terms of Linux exit syscall. And then the argument comes in via RDI. And the way I think I'm going to do this is just have the last thing on the stack be the exit syscall. So this would just pop into RDI. Then that will exit with whatever we put into RDI. So in this case, it'll be 40 from all this. Yeah, I think that's what we'll do. That's roughly what we want to generate once we get to generating things. And now we actually need to read the source code. Let's do that. This is going to look very similar to the Ziglex, tokenizer, just because it's laid out very simply. It doesn't need to be anything fancy. We'll have our source, we'll have our cursor we're currently at in that source. And we have a next. This will just return a token. Go define what those tokens look like quickly. There'll be some kind of token tag and some kind of token location. The location will just be the start and the end byte positions exclusive on the end. This is a half bound. Then the tag just going to be an enum. We have an invalid tag, an end of input tag. We have integers. And we also have plus. So we do it like this. Makes sense. We want to keep track of our start position. And we can do a switch statement with a label, because what we're going to do is just use this as a state machine, which we can do very nicely in Zig, thankfully. What we can do is we'll say we have a state. We'll have our start state that we just defined. We'll have an invalid state for if we're in the invalid mode, and we'll have an integer state for when we're reading through an integer. That start state, we're just going to look at the current byte that we're looking at via the cursor. So in this case, if it's 0, we'll just we'll check if we're at the end. Just because it's null terminated doesn't mean the null is the end of the string, or the byte slice, I suppose. So we'll check whether the cursor is at that scanner's length. And if we're actually at the end properly, we can break our state machine. So this will be state will break with the end of input tag, and the location just be the scanner cursor here, because it's the end byte, so there is no width to this, it's just a position. And then the end will just be that same cursor position. If we're not at the end, so if we've hit a null byte but we're not actually at the end of the source, what we'll do is just go into our invalid state, I suppose, since it's invalid to do so. And then if we don't match anything else in here, this will go to invalid too. And the only other two things, well, three things, we want to skip over white space. So we can just increment our scanner's cursor, because we don't do that in here, so we need to do that. We can set that start position to the scanner cursor, because we just want to skip over it and not keep it as part of the token's size. And then we can just continue in our start state. The next one will be plus. Plus will also increment that cursor position, because if we don't do that, we'll just be looking at plus the entire time. Then we want to break with our token. In this case, the start will be start and plus. And the final one is 0. 0 through 9 anyway. In this case, we just want to continue straight to our integer state. It should do us good, I think. Yes. Right, so if we're in our invalid state, for all of these states, we're just going to increment our cursor up front, because we've already looked at the token to know that we should be in this state. Then here we'll just do our scanner source, scanner cursor. So if we're in the invalid, if we see that a null byte, which will signify the possible end of the source, we do need to check whether it is actually the source's end though, so we'll do that as well. So if we're at the end, space, new line, tab, carriage return, then we'll do this. If we're at the end, this is only really related to this, but we can just check it in all cases, it doesn't really matter. If we're at the end, then we can break from state with an invalid token. Let me just grab this and replicate. If we're not actually at the end, we just want to continue in the invalid state, because there's still more stuff and this was invalid to come across. Then otherwise, we also just want to continue in the invalid state because we're still looking at invalid stuff until we hit one of these points. Then the integer is the other way around from invalid, where we don't want to do a loop until, we want to do a loop while. In this case, it will be if we see 0 through 9 or underscore. We're going to allow underscores in our numbers, why not? So while this is the case, we continue in our integer states. Otherwise, we break from it as an integer because we have finished reading our integer. That should pass this file perfectly fine. Hopefully. Let's check that out, make sure it does. We can do our argument passing straight away, why not? What we will do is we'll say init minimal args. And this takes in the GPA, so what we'll do is we'll just destructure it slightly. So we'll say our GPA is this, then I'm going to wrap this in a block just so when we defer, all good. If this runs out of memory, I am just going to an inline fn return out of memory. So if we hit an out of memory, I'm just always going to it. And here we have our args, and we can defer args, the init. Perfect. Then let's think about how we're going to be using this command. So we have a usage. Our usage will consist of running fabc. We'll take in an input, I suppose, which will be the input file. Do we need anything else at the moment? Nah, let's just do that for now. So we'll say standard debug assert args skip. There should be at least one argument, which will be the program's name, or well, not name, but path. Sorry. So we'll just assert that it exists, because if it doesn't exist, then none of this is going to make sense anyway. So then we can grab our next, and let's just say, I don't want to do this. I think I'm going to just go with there being an input path. So just undefine that. Yeah, that seems fine to me. So what we'll do is just say that we grab the input path temp. Yeah. Or not temp necessarily, but arg. Otherwise, if it doesn't exist, we'll just process exit 1. Or yeah. Just return error. No input path. We'll just do a standard log error of usage. That should work fine. So if we do come across it, that will just be stored in here, and then what we can do is GPA dupe be a UA of this, and then that can become the input path. This can fail, but if it fails, it's just an I like calling it stupid. Anyway, that should give us our input file. So if we just info the input path, sorry. We also want to, since we're duping this, we do need to clean it up. We don't need to, but we're going to clean it up. So we'll just do a free on our input path. No, because this is returning. We'll do all the defers down there. Sounds good to me. Yeah, so no input path. It could be nicer. Do that. I'll do no input provided. It's a bit verbose, but we'll have all of it. Maybe not. I think thinking about it, you could just return one like so, can't you? Oh, and input returns. Yeah, I need to return 0. Yeah, okay, that works well for me. All right. Yep. So no input path provided. And it prints out the usage as well. Sounds good. Looks good even. And then if we Yeah, so if I put this up here, this would be incorrect because we're trying to clean up memory doesn't exist. So yeah, we're all good. I just wanted to make sure because I wasn't entirely sure if defers wait to be added to like the defer scope properly until after the executed area. And it seems they do, which is nice to know for future usage. Okay. Anyway, all right, so we can now read this file. Let's go do that. Let's say we have a input file. We need to read through CWD, so let's grab the current working directory, which is standard IO dear CWD. And my hands are just at the wrong part of the keyboard where I keep on pressing all the wrong keys. Perfect. Need to get it in the right area. Anyway, so CWD, we're going to open file using IO. IO, as in that IO. Thank you. Subpath will be the input path. Any options we care about. We don't want to allow directories, so let's set that to false. Other than that, that looks good to me. So this can fail for a multitude of reasons. Let's catch that and we don't need the usage, we just care about outputting some kind of message. And we'll also provide the reasoning that we're given. So this will be could not read, could not open the input file. I'll give the file name back. Yeah, why not? Could not read the input file. Is it necessary? Do we need to? Not really in this case. We'll just leave it like so. Then we need to destructure our IO out of there as well. Say destructure, it's not quite the right word, but you can say. Then we can close this once we're done, which we are now done. It should just do anything. Let me say test.fab. So that seems to be opening. And if we were to give it something faulty, it says it can't find the file. Perfect. If I gave it /fab, it couldn't open it. It's a directory. Okay, cool. Just testing a few scenarios out here. Now that it's open, should be able to create a memory map. No, let's not do that. We're looking to create a reader, but I'm wondering if we can directly read without having to create a reader first. I don't think so. I think we must create a reader. Length. We can get the length. So yeah, so we if we're reading and allocating, how does this get handled? We do std IO file reader. I want to know roughly how they handle their interface. In the interface. I don't think. I don't think there's a like special casing to get the size of the file first and then read that. Does it even matter? I mean, it's nice. So what we'll do, yeah, we'll do this. So this will retrieve the ending byte index files. Yeah, only the lengths need in this case. So that this can fail for reason. Like, can this fail? I'm not too sure. Some kind of interest. Access denied on WASI. Permission denied would be interesting given we already opened the file. And on file stream. Alright. Then unexpected and cancelled. Yeah, let's just go to done way for now. So we'll say create a reader. have some kind of input buffer, sure. 024 should be good for now. Really. Then we'll have input. Now we should be able to. What is it? We're looking for interface. Alloc remaining. And we want to alloc remaining align sentinel because we do care about having a sentinel. Taking our GPA, we'll say read everything, so unlimited. This will just be 1, and the sentinel will be 0. This can fail for a few reasons because the read can fail or the memory allocation can fail, so let's check. Out of memory. This calls our and right, no, right, sorry, read failed. We'll do just a nice error for, I suppose. From the input file. And then this will be 4 reasons, which will be the input reader error. Can it be any of the other errors? I'm not entirely sure. I'll just keep it question marked and not unwrap it here for now. I mean, I could print all of them out. I'm not sure that's particularly. Anyway, if we do this, we should now have our source. Indeedy do we do. So we can just GPA free this once we're done with it. And if we run this, it fails because it must handle all. Stream too long. Stream too long shouldn't. Because we're looking for unlimited anyway, so this is unreachable. I am silly. There we go. All right, that worked and compiled. Let's think. What next? Well, we want to create a scanner where the source is the source. Then we can get our next token. We just print out all of the tokens for now. Standard log. If the tag is end of input, then we'll break. That seems correct. 0 to 2, 3 to 5, 6 to 7 for that, and then 8 to 8 seems correct to me. For this input. Good to know. Yeah, right. So now we need to do some fancy stuff. We actually want to generate an executable that does the stuff. I am going to add the step in of having an IR, because that will be very useful when we need to start doing, you know, ifs and loops and stuff like that. And I have a fun idea for the loop and conditional situation, which we'll figure out once we get there. For now, we'll have some kind of IR. And this will be passed from a scanner. Seems reasonable to me. Yeah, that seems good. So let's think about what we need to be able to do in terms of our operations. We need to be able to push some immediate value, and we need to be able to add stuff that's on the stack. And this should be an enum. Seems reasonable to me. The push immediate does also come with the caveat of requiring a value, which we can just encode in a unit enum for now. And we're just going to assume there's only I64s and nothing else. Seems like a reasonable choice. So yeah, let's try and force through this. What we'll do is we'll just take what we're doing here and just break it down a bit more, I suppose. Let's switch over the token tag. We have some errors. Alright, so do we want to do something interesting here? I'm thinking maybe we can have a sort of validate, I suppose. And it's not really gonna work. That would require the token stream to not be a stream, but to be a well-known list, which we don't have. So yeah, maybe not. I am indeed. I have written a few things here and there in Sense compilers before, so nothing like how I'm doing it now, where I'm doing the actual generation without a backend, but it shouldn't be too difficult. It should be pretty easy, especially for the constraints we're working within. But yeah, it's nice to see you as well. Yeah, let's get this going. So if we're invalid, I'm just going to return some kind of error, I suppose. It'd be nice to report where that error was. So what we can do is, instead of just straight up doing that, we'll collect some kind of errors list. I think seems reasonable. What we can also do is we can collect our tokens into here too. Token. So we can say that the main token, I think I'm nicking this name directly from the compiler. I've looked around the Zig compiler itself a few times. So I'm guessing I'm just nicking this name from the AST generation stuff. But this will just be a token index. So we'll say U32 here. U size. I'm not trying to make the most efficient compiler in history compilers. So we'll just say that's that. We'll have some kind of tag for this as well. So let's think. In terms of tags, what do we have? I'm going to say invalid token is a tag, because if we come across an invalid token, that's its own issue. Yeah. I think that's the only one I'm going to worry about for now. Thing is, we could do so much stuff in here. We could also do the type checking at the same time if we really wanted to. And maybe we do, maybe we don't. What I'll do, so call this the high level IR. That's what we'll do. Is it similar to fourth? It's going to be concatenative, yeah. Similarity to fourth wise, I'm not entirely sure. I haven't used fourth myself. I do know that fourth is a concatenative and I believe stack-based language. So, in that sense, I'm sure. I haven't, as I said, used it myself or looked too far into fourth. I do know there's some funkiness with how data types work, though, if I remember correctly, because everything is just words, machine words. So you have to go about implementing data types according to that, if I remember correctly. That's about the only bit of knowledge I have. Even if that's correct, I'm not entirely sure. So what we could do is just grab our token, which will be a standard token. And same thing for errors, which will be that. And in these cases, we're going to be converting these into owned slices. So the only time we need to deinitialize these is if an error occurs. So we are going to need our GPA in here as well. GPA standard mem allocator, which I am going to return the error for, even though I said I'm going to do the stuff everywhere. I'll do that outside here in one place instead. It'll be the same for errors. Yeah. It's been a while since you looked at fourth. Yeah. As I said, that's roughly the only bit of knowledge I have of fourth, so. I should probably do some looking into fourth. I think that'd be fun to do at some point. Whether that be on stream or just personally. It's got that right level of a bit of esotericness by the sounds of things. Very low level and been around a long time. I think it's been around a long time. Okay, and we also want to store our operations. I'm going to call these nodes just a random injection. We'll say nodes. Node. I could probably use a multi-array list for this as well, but I'm not going to worry about doing that. It would help in terms of some of the memory for the nodes where I think all of the nodes except for the push immediate are going to be empty on their data side. Not necessarily true thinking about it. It'd be useful to keep track of information such as where jumps go to in terms of node positions. So yeah, I'll see what happens. Anyway, we have all of that going for us, so let's say, if we're in this case, we're always going to want to push our token. So let's just get the token index. Yeah, I saw. I think he's paused development for quite a bit now. But yeah, I did actually watch that series. I do like the idea of just using an assembler as the backend instead of having a backend. I personally haven't ever interacted with LLVM. I think I've very briefly done so with QBE. And other than that, I know CraneLift as well. I've touched CraneLift. I haven't done LLVM because it's such a big beast. I know you can get optimized programs out of it. It's just not that interesting of a proposition to me, though. Not that I don't like optimization, just that for how complex it is, it doesn't really seem worth it unless I'm trying to, actually develop a proper language. So I either end up just doing the assembly thing, like Zoding did, or, well, apparently this today, with the whole writing out the machine code and elf object manually. This will be the token items length. Then we can try token and yay the token. Good to see a fellow Zoding enjoyer, by the way. I do enjoy his stuff. I haven't really kept too close a track of recent things, but I've watched quite a few of his older stuff in like back catalog. Been good. So for this, we're just going to try errors and GPS. See, if there are any errors, then that will just say to us that the source wasn't fully correct. So don't expect the nodes to be entirely accurate and or valid as a sequence of operations. I think that's how that'll end up looking. The error, the tag is going to be the invalid token tag. The main token is going to be that token index. Other than that, that's all we have for now. Until maybe another bit in the future. If we hit the end of input, then we just break because it's the end of input. MongoDB's things extracted. I'm not entirely sure. I think this is a punt given at random file names I've seen in a Zig compiler. I believe they emit LVM bytecode directly. I don't think they use the C API necessarily. I could be wrong there. Unless that is how you interact with it via the C API, I'm not entirely sure. Yeah, and Zig is trying to transition. They have their own X11, sorry, X11, x86, 64 backend, and I think they got ones for ARM 64 and RISC-V. I'm not sure how far they're along, but at the moment I'm using their debug backend, which does use the x86 64 backend that they have. So it's been working great. I know there's some issues in terms of linkage still because the linker's in work. But it's been good. It's very quick. It's nice to see. It's also cool just to see people doing stuff, enjoying the low levels development. That's why I find a lot of my fun doing this. So for plus is very simple. Plus is just going. Actually, wait there. That's a point. I could have an error node which points to a specific error, maybe. Put a to do in there. Error node points to the errors index. That could be useful. Here we're just going to do nodes append. And in this case, it will just be a. Actually, this will just be add because it's acting as an. Maybe. As I said, I haven't really messed around with LLVM directly before, so it could be. It might be a fun topic looking into how the LLVM bytecode looks and trying to omit something valid and getting that to compile. But for now, I just want to omit x86 64 machine code and write that into an executable elf for today. Maybe another time, that'd be pretty cool. I'm up for suggestions always, because there's so many fun project ideas and I don't know all of them, right? And the only way to find new ones is to ask people, unless I come up with it myself. So for our integer, we want to push the immediate. And that immediate is something we're going to have to grab. The way we can do that is by doing a format parse int s64. We need to give it that slice, and I'm going to say base 0, which we'll just figure out based off the prefix. Yeah. Otherwise, it's base 10, and it ignores underscore characters in the buffer, which is nice, because we allow underscores in it, which is why I did that, because I know this does that. And then the slice is just the scanner dot token lock end. And then this has two errors, overflow and invalid character. Overflow we do care about. Invalid character shouldn't ever come up though, because we are making sure it's valid when we tokenize it. So how do I want to handle this? We can say invalid integer. We can just blanket this as an invalid integer, I suppose. So let's do this via an if, I guess. If there's an error, we'll do one thing. If it's valid, this one. Is try errors append. Yeah. Main token index. I probably could just store the token on the error itself, given I don't really care about the efficiency. I don't care about the error there either. Yeah. Good. Methinks. I'm going to separate those out. I'm going to separate them out here as well, just because, you know, we add minus and other symbols and other literal types and such. It'd be nice to have them separated out. Plus, it just makes this a little bit more readable. This goes with that. Okay. Let's try and create something actually. We need our D in it. So we'll take our here in disk and take in the GPA. I don't even know if this is still best practice or not. Well, not best practice, but good practice. But I'll do. Then we can. This will be GPA. And is perfect. Oh, and when we exit from here, we do need to convert these into something useful. So let's do that. So this will be a try slice GPA. Then this can just turn Actually, I'm going to call it owned instead of slice. Symbols. So from here, we should be able to get our high-level instruction, intermediate representation, sorry. We say pass, scanner, GA. We catch an error. This error is currently only ever an out-memory error, I believe. Let's just go with that being the case. If that changes, we'll know because we've now specified what our errors are. That'll be good. Then we can do is we can say here errors length not 0. If this is not 0, we're going to return 1 and we're going to edit these errors for the user to see. We'll say for here error. Yeah. I suppose I'll just say E because error is going to be taken already as a keyword. And we have the tag and the main token. I'll do. What's the basic format for this going to look like? I'm not going to worry about getting source locations in terms of lines and columns. I'll just keep it as byte locations for now. So we'll have dd to d. Put the file location there. So this will be input file. Oh, sorry, input path from. We need to get a token. Token will be the here tokens, the main token. That should be valid. Perfect. This will be the token lock start token end, and then we'll print out the error nicely, I suppose. So to do that. What do we want to do? Oh. I suppose what we can do is for the tag here, implement a custom format method. Tag. And then we can just switch over the tag. Valid token will just be I writer write all valid token. An invalid integer will be invalid integer. Not the most creative errors currently, but at least it's a bit more specific. I mean, invalid integer could fall under invalid identifier. It's just nice to give that extra bit of information, like your integer you provided. We saw it was an integer, trying to be anyway, but it's invalid. Sorry about that, Chief. What we can do here then is, instead of doing a string, tag. Yeah. A bit of that, do a bit of that, just so I'll try and keep things under 100. General width I go for. Oh, and we have. Oh, because we're not cleaning up. Yeah, that's my fault. Sorry. So here we'll just do a defer here. Okay. Found constant. I don't need to do that yet. You're right. It's fine. There we go. Okay. We didn't get any errors. But if we were to make this really big, then we'd get an invalid integer from 3 to from byte 3 to 26, which makes sense because it's 0, 1, 2, 3. Then this is 23, so it ends up being 26 because 23 plus 3. Good. Yeah, and then if we just have an invalid thing like hello, because we don't have any kind of identifiers yet that says invalid token, just because it doesn't even understand what you were trying to do, because it's not a concept inside of the tokenizer yet. Perfect. So if this does like higher level parsing, making sure everything's correct, getting our operations out into some kind of format, but it doesn't do types or anything like that. We're going to leave types for a second. I think I'm just going to try and generate some, generate an executable based off of this high level intermediate representation. And then we can move on to doing it based off of a lower level one if we want to start bringing in some like semantic analysis and whatnot. Seems like a fun way of doing that. Okay. Obviously, we're also not doing anything complicated here. Like, things will get more interesting once we start doing more complicated stuff. Using this level, if there are no errors, we know that this should be just a valid high-level intermediate representation. That language. If you're talking about the language I'm programming currently, that's Zig. If you're talking about the language I'm making, then I've called it Fab, just because I like the ice lolly. It's nice. Yeah. Hopefully that answers your question, one of those two. If it's not that, then I don't know what your question was. Never heard about Zig? It's an interesting one. I've been enjoying it for a while. I'm sure it's probably not up to everyone's tastes, but if you're looking for something at low level, and you're looking for something that works well across platforms and whatnot, it's a good language for that. I've a good example I can give is WebAssembly. I'm not really someone who's used too much WebAssembly. I find it interesting, but I haven't really had too much of a need to legitimately use it. And Rust is the go-to language for WebAssembly normally. But I find Zig just works better if I'm trying to do something, even for it. And Zig doesn't really boast, you know, in terms of like being the WebAssembly language. But it just works. You compile, it does what you expect it to do. There's no fancy wrappers. You don't need like a WASM bind gen crate or anything like that. You can just do what you want to do. I mean, you can do that in Rust as well. Don't get me wrong. But in terms of out of the box experience, I think it ends up being nicer. And I think it's just because it's lower level than Rust. You know, Rust is more like a C++ adjacent, whereas Zig's more of a C adjacent language. Both are great for different things, though. I don't really care about the whole language war thing. I just like using tools that feel good for the job, you know. I start generating some code. I'm not going to worry about separate targets currently. Nah. I mean, I'll worry about it in the sense of I'll pretend they exist, but they're not going to exist yet. So I'll have some kind of like x86. I cannot type x86. There we go, 64 submodule here. And this will contain, we want a codegen function, I'm not entirely sure. So we're not going to need to generate any section. No sections are going to be needed. Since we're just generating executables and I don't care about the linking side of things yet, it's just going to be an executable, so it'll just be straight machine code that we need to worry about, which will be nice. So let's do that. We'll have a codegen function. This will take in a high level, a here, and then this will just output the machine code, I suppose. And this will just be an error out worry. Oh yeah, and we're also going to want our allocator to do our memory allocations with. Yeah. So we'll just make, I'm going to make a writer, and it'll make sense in a second. We'll say standard IO writer allocating, init that with the GPA. Once again, we're going to be taking an owned we're going to be taking the memory as an own slice, so the actual allocating writer doesn't need to be deallocated. The only time we'll do is if we want to error with an hour memory, so we'll just do an error defer. Other than that, we're just going to be returning code slice, which, as I said, we'll just return the actual own slice, and the outer memory happens because it does a reallocation to shrink the memory down to the correct size, so you don't leak any memory, which can technically fail, even though it shouldn't really fail because most systems just shrink the memory you own, free up the bit you didn't use, so it keeps it in the same place. But you never know. Anyway, errors. I'm going to do a standard debug assert that the error's length is 0. And reason being is I expect that to be the case. If that's not the case, then you've given me a high-level intermediate representation that possibly, does have errors. Yep, 016. So yeah, we don't want to be dealing with invalid operations. As I said, they can be invalid if there are errors, because we're not saying that though. We're not doing like a result in terms of a matrix. It's just we have everything in one structure, including errors. So yeah, that should be fine now. So I suppose for now we can just loop over. Loop over the nodes. Should work. We can just switch over the node. Then if it's push, do different things. I don't know why I'm grabbing these from here. I could have just typed them out. It was particularly difficult. So how do we do these two things in x86-64? Go look at that. So there's ref x86. I think it's asm.net. It is perfect. Flashbang. What to say there would be a flashbang, but there'll be flashbangs. So yeah, 4-bit ABC. So we have it in mnemonic order. We care about doing. We're trying to push an immediate, so this will be a move and then a push because we need to push a 64-bit value, which we can't do just via a push itself. Let's go have a look at the moves. Be this block here probably, known as floating point. Yeah, here's our regular moves. So we need to move an immediate value, so one of these capital I ones into a register. And we want this one, because this one's just for bytes, this one's for quad words, double words, or words. And remember, a word in x86-64 is 16 bits still, because it's originally a 16-bit platform. It's just been extended to 32 bits and then 64 bits. So quad word is 64, double word is 32, word is 16. Yeah, we're going to be using this one. This column here is the opcode, so this is B8 in hex, and then this plus R means that we're adding the registers encoding, which will be 3 bits, onto the instruction opcode to choose the register we're moving the value into. So if we wanted to move 6 into racks, that would be 0xB8 plus 0B000, because racks is the first register, which we can see if we go to, I think, OS dev x86-64 instruction encoding has that information. Once again, another flashbang. They do have a dog mode though. I don't think Geek, whatchamacallit, the x86asm.net website does though. So I'm just going to leave that as is. If we look here, we can see there is the encodings for each of the instructions. These 3 bits are the ones you care about here. These ones before the decimal point are the extended. which is how you access R8 through 15. And to do that, you need to change the recs. And I think that's it. Because you have a mod RM byte, which if you're not using the adding of the register onto the opcode, you'll have a mod RM byte to choose your registers, and you can use the rex prefix to extend the the RM and reg register choices inside the mod RM byte to be this set instead of that set. It gets a bit confusing. It's an old, funky, extended beyond all comprehension instruction set. So yeah, in our case anyway, besides the point, we want 0xb8 plus the register. So we'll just try code writer A plus 0b. So in this case, I'm just going to use rax, because rax is like a scratch register. So we'll just push into rax, and then we need our immediate value as our operand. Do a code writer int, writing a 64-bit value is just going to be the immediate, and it's going to be a little endian. There is a problem here. As I said, x86-64 has been extended over time. So this, I believe, will work for 32-bit. So this will be targeting EAX, not RAX. We need to target RAX with a 64-bit operand instead of a 32-bit operand, which means we need the rex prefix to have the W bit set to 1 so that it knows it's a 64-bit operand. So what we can do is we can write our byte for our rex prefix. This will be 0100, which is just a fixed thing to say this is a rex prefix. And then 1 is the first bit, and then the rest of the bits we want is 0, so now. And that should be equivalent to doing a move rax, whatever the immediate is. Now we need to push rax onto the stack. So how do we do that? There we are. Yeah, we just probably want this first one here. Once again, we're adding the register that we care about onto our opcode. So 50 plus, you know, in our case, 0 because it's rax. Do that. Code writer. That should push rax. Okay. And what I'm going to do, say, yeah, catch, and this will return the code. And then I'm just going to write this out to an output file. So let's take in an output file as a, let's do it as an optional. I'm going to make this the same as how Phasm works. We look at Phasm's thing, it takes in a source and an output. So we'll do that. If you don't provide an output, it'll just be a.out like it normally is with compilers on Linux. I think most Unixes as well. It adds a little complexity. It's fine. It's not actually that much complexity, to be fair. All we need to do is args next, or else a.out. Path arg, and I'm just going to do the exact same thing to the output path. So yeah, we are heap allocating a.out when we don't need to if you haven't chosen one, but it's fine. It doesn't matter that much. We're all right. And we do need our output path up here as well, like so. And we do clean up. Let's go about opening. I'm just going to copy this. This is going to change, so we're actually going to rewrite this bit. So output file is going to be twd.create file IO. Subpath is going to be the path. And the flags, let's go have a look at the flags. I believe in the flags we can set permissions. Yes, so we don't care about changing any of them, any of the... No, we don't need it to be variable. We want to truncate. Yep, sounds good. So permissions, we want this to be executable file. Now we'll just make it executable, which is what we want anyway. This bit will actually be pretty similar here. Similar to here, anyway. Just we could not create the... Then we'll close the output file. Output. There we are. Buffer. And we want a writer for this. And this is a writer. Nice. And then all we have to do is, for now, we want to, actually before we do anything, flush. Don't forget to flush. In the words of Andrew himself. Andrew Kelly, that is. This is only our write failed. Okay. So write fail, we'll just pretty much copy this and switch this to output. Error. Is there any kind of errors? Yeah, there's right file error, big error, and error. So really, I should be probably checking all of these. Okay, what we'll do, because we're feeling fancy, is or else. What other errors are? Seek or else. Size error. Sure. Just in case it's any of those reasons. I'll do an or else, that error, seek error, or else. Probably not correct, but you know what? Who cares? It's working. Hopefully. Hopefully it works. Yeah, could not write to the output file. And this is going to be similar to we try and write everything in. So we'll just copy that. We'll say output interface. It's all good. Not sure how complete it is, but standard Zig LVM has some big code. I have seen it. Oh. Okay. Yeah, I haven't checked myself, but I can have a look. Let's have a look. Standard. I know I could open this up in a place, but it's fine. 016 specific. 016. There we are. Okay, there's a builder. There's a bytecode, bitcode reader. Okay, this is more than I was expecting, to be honest. There's a writer as well. Oh wow, okay. Okay, this is a lot more complete than I thought. I didn't expect this to be in a standard library. I thought this would be part of just the internals of the compiler as well, if it's used internally for the compiler there. So that's interesting. Well, I have another venture I can look through, so thanks for that. I like reading through random compiler code and standard library code. So, thank you. Anyway, we'll write our code. Optional time. Oh yeah, this isn't... I mean, this is optional still. Let's make sure we're out snulling this. Because if it's not there, then it's not there, and that's a tone issue. This one here, if that's not there, then I thought that would be optional anyway, because these are all nullable, but I suppose this isn't the issue. Maybe that isn't the issue, maybe I'm just not reading correctly. Found that. Found that, or a possible error? Yeah, well, these are errors. Huh? Found that. Is all elsing this funny? Is all elsing this somehow turning it into error out? Okay. What was you trying to do with the LVMIR field tool, if you don't mind me asking? Or was it just to, you know, dump things and see what it looks like? Okay, I'm just going to worry about this. It's not worth the effort for doing. Down, now, right, failed. Because this can fail. Well, this only fails if there is an out of memory. So this will turn out. Leaked. Ooh. Oh, because I'm not cleaning up. Yeah, that's my fault. The fur EPU. Right, that cleaned up, and we wrote an a.out because we didn't provide a file path. So if we object dump this, we should see some stuff. Dump. I think it's capital D to show, well, disassemble everything. Then it's E, the format, which is binary in this case, and then lowercase m for the architecture, which would be 386 x86 64. Then we want an Intel, so I think we do here as well. Oh my god, I actually remembered how object dump worked first try. How about that magic? Anyway. So we're moving into racks, which is correct. And we're moving a 64-bit immediate, so 0x14 is 20. Because it's 16, 116 plus 4, which is 20. Then we're pushing racks, which is correct, and then we're moving 22, because that's what 16 is, into racks, and then pushing racks again. Perfect. What I'm going to do is, because we're going to be doing this for a little bit here, I'm going to grab this and add this onto the end of this, just so we can see exactly what's going on each time. So now we just need to do our add. And add will require us to pop stuff, and if I remember correctly, popping is 58 instead of 50. Yes, so that's popping into racks. We don't want to pop into racks, so we want to pop into... I'm going to use the System 5 pool convention for like, even the internal intrinsics. So we want to pop into RDI. So RDI is 111, and then RSI, which is the next one, is 0110. Sorry, 0B110. I believe Wikipedia has a page on System 5 ABI and Chon. Or System 5. Okay, it does have it, it just isn't in so and so. So yeah, it's RDI then RSI. So let's double check. The RDI 111. And then RSI, which is our secondary. So we want to do this in first, right? Because we're on a stack. So we want the second argument first, because I want, when you're reading this, when you do an add, I want you to be able to say left and right, not left and right, just to make it nice and human. So I'll flip those around. Obviously for add, it's associative, it doesn't matter, but I'm going to do it just so it's done. It's been a while since you worked on it. Okay. Okay, yeah, I see, alright. Makes sense. I mean, even if it's been a bit, I'm sure it's a fun project. I can't look at that just yet. I'll have to Look at like so. Copy link. Then I put over LV, MIR, and Zig. Okay, well, I'll keep this around because I'll have a read through this the stream. Thanks for that. Okay, so my RDI, we don't want to push, we want to pop. These should be popping. Have a look. Let's see if it's doing what we're expecting it. Get this popping into RSI and then popping into RDI, which is expected. Then we need to do the actual add. So the add will be probably one of these. Question is, do we want EVQP and then GVQP, or do we want it the other way around? I can't remember. I think we want it this way around, so I think we want 0, 1. And then R here means that it's going to be in the mod RM where we specify our registers, not in like addition on top of the opcode. So that'll be fun. We'll have to do that. So we'll say 0. Add RDI, SI. Then we have a mod RM byte. 0B. It's 114 register direct addressing, I believe. Then we'll have 123, 123 for our reg and RM. So I can't remember which way around these are going to have to be. So we'll just think it'll be 111, 11 here. See what that looks like. That's add ESI and RDI. Oh, so we want these the other way around, I believe. Yeah, and then we also want that Rex on here as well with the 64-bit operand, because that's saying also make the register 64-bit in this case. Perfect. All right, and then we just need to push RDI, which is the same as popping RDI, just we do it at 0x50 instead of 0x of 58. Like so. Yep, perfect. So this should do those two operations that we have. Now, we also, in, as I said, this case, we can't just return, with a return instruction, because that's not what the kernel's expecting us to do. What we need to do is tell the kernel we're finished executing, so we need to exit, and that'll be via a syscall. And we can just do that at the end, but this is more of a target dependent thing. So if you're on Linux, it'll be one thing. If you're on Windows, it'll be another thing. If you're on Mac, it'll be another thing. I mean, I think Mac probably uses the same, well, similar method, but yeah, we're just going to deny that. Thank you, my friend. Anyway, so what we can do is probably just do some. Okay, so here's the thing. That's not what you want to hear, but here's the thing. What we will do here instead then is we'll accept the code standard IO writer. Here, we will instead create this here. And I mean, this can just be written directly to the output, but we're not going to do that because we need to do the ELF stuff as well, which will be fine, actually. Screw it. No, we don't need a separate. Just give it the output. I'm just going to call it writer. So this won't be out of memory. This will actually be whatever the error was. So these become tries. This is no longer this. This is whatever the. This will be a standard IO to error. So, okay, and a GPA goes away because it's no longer in use. So we need this here. And the reason I'm doing this is this also doesn't exist. Is because a pub Linux, for example, right? Yeah. This is going to be Linux x86-64 specific though. Still. So it's kind of here and its own thing. So I will smash this into here for now, I suppose. So this will be the exit. This will take in this. And this as well. And what we'll do is we'll just use the last value that was on the stack as part of our exit. So this will just pop into RDI and then move to RAX 60, which is the exit syscall number on Linux. Let me just copy. Don't need this. This will see. And then syscall, which I believe is 0x0f0x05. So we'll say try writer right. All. Need to fix all of those as well. It should just be syscall. These aren't writer or writer, which is nicer as well. So it's good for us, I suppose. So yeah, we want to do not this. x86-64. Gen, the high level intermediate representation, and then let's put writer.interface, and then we also want to do .exit. And both of these can fail for this reason, so let's just do that. Okay. That should be everything, right? No GPA. GPA doesn't go there anymore. Where am I? We don't need to code gen here anymore. There we are. Yep, so expected one argument found 2. This doesn't get given the intermediate representation because it doesn't need it. Okay, perfect. And then yeah, syscall was correct as well. 0f05. We're pushing 3C, which is 60. Perfect, and yeah, we're popping into RDI. So we push to RDI, then pop straight back into RDI. As I said, we're not doing optimizations right now. The thing is, we can do that using our high-level intermediate representation. We can then lower that into like a mid-level or a low-level and do some optimizations, such as collapsing constants and doing some simple interpreting. Anyway, that should be good. If anything, what we should be able to do now is if we memory mapped a location in memory, obviously. But if we did it with mmap, we should be able to say it's executable and readable, and then have this run like it's being jittered, which we're not going to do. I'm not going to worry about saying that because I just want to get an actual executable file ran out. For now, we're pretending our a.out is an executable file. Okay. I think the next bit, yeah, the next bit should be fairly simple because all we need to do is write some struct. Interface, write struct. We're writing standard elf, I believe. Elf64 EHDR, yes. And we're going to be writing these in a little endian because that's what we're using. And it's, you might think it's a little bit cheaty, but this is just the actual structure. It's nothing fancy. So this is just as if I had written the structures out myself. I'd be doing the same thing. So the ident, this one's going to be a bit annoying because we need to actually pack some stuff to a location. We'll say ident, just into a buffer, sorry, ident. Say ident, it's tgelf ei splat 0. So I do want this to be zeroed. U8s. Ident has a few things in it that I do not remember, so wiki elf format should bring us to, yeah, perfect. Yeah, so there's a magic, which is the elf magic, followed, preceded by a 7F for reasons. What we can do here is we can just say mem ident 0 to standard elf I. This will be standard elf magic. Think or magic length? No, so we just say magic, not length. I'll be fine. The next thing is the class. So at ident standard elf magic, sorry, EI be inf standard elf class 64. Yep. I believe the next one is data, which is LSB. Let's double check. It is, and then versions 1. Then it's OS ABI, and then all padding, because this is never used as far as I can tell. So it's versioned and OS ABI. OBI. So for the version, this is just always 1, because there's never been another version. OS ABI will be, I think it's none. Yeah, even though it's not none, it's System 5 ABI, but you know, I did write the elf spec. Okay, I'm actually going to open this up in a separate tab. Okay, that's not what I asked. There we go. Yeah, just making sure it wasn't frozen. So next one's type. Type is going to be exec. This is an executable. Machine is going to be x86-64. Version, which we're doing again for some reason. Entry, so this will be the entry point. I'm going to do a little trick here, where instead of having a bunch of padding for no reason, we're just going to pack the code straight after the headers. So to do that, the alignment's going to be 0, which means I need the entry point, sorry, not the alignment, the loaded parts, the program header which loads everything is going to include the header, which means I need to set the entry address to whatever its offset is going to be, plus the header locations. So we'll say, I think it's 40,000 is the common one that you see for like the GNU stuff. So I'll say 40,000 plus 40,000 in hex, or more specifically, plus the size of 64 header, and going to need one more header on this as well, which will be the program header. And I'm very much hard coding all this right now, but I just want something that works. So that's fine by me. So the program header offset is just going to be after the main header. So that the string header offset is not going to exist because, oh sorry, string section header offset is not going to exist because we're not going to need it. The flags are always 0 because they depend on OS ABI, so we don't touch those. The header size of this header, because reasons, is its size. The program header, not program header, sorry, yeah, the program header sizes are the size of the program headers. There's probably reasons why you can change these, but I haven't seen them changed. phnum is going to be 1, it'll be 1 program header. The shent size, the shent num, there'll be 0 section headers, and the size of a section header is the size of a section header. And then the string section index is 0 because we don't have one of those. Whew. And now we just need to do our program header. And then if this fails, we just want to do these. I'll forget that. P. Get rid of all of this graph. There we go. So for the program header, we have the type, which is load. We have the flags, which include executable and readable. Sounds good to me. the offset, so where we want to load this into memory is 0x 40,000. Sorry, not the offset, that's the wrong one. The virtual address we want to load this is that. The physical address we want to load it is nothing, because I don't care about the physical address. The offset is the offset in the file that the code starts. And the code starts after here. And then the file size that we want to load is... Ooh. The file size we want to load is whatever the size is of the stuff we code gen. So maybe we do need a separate code gen step then. It's fine, it's fine. So code is standard IO to allocating init GPA error defer code D init. I'll say code writer. Then I can say code is going to be the code writer dot slide. Actually, no, we don't need to slice this anymore. What we'll do is do this, and this won't be error defer. This will actually just always happen because we can just say code dot written, and that will give us everything. Nice. Yeah, but we want to run these, but we want to run these on the it's here, and then this will actually just be the again because yeah. At least we can rid of some craft, I suppose, if you want to call it that. Yeah, and then the file size we're loading is just the code written. Then the mem size, which is how big it'll be in memory once it's loaded, is the same. The reason they're different is because we could be loading something that we want to just be cleared with zeros, but not actually be written in the file because that would be a waste of space. So it might be zero size in the file, or have some predefined stuff, but not all of it's predefined because we want the rest of it to be zeros. Then the mem size is the full size of the actual section. Then the alignment is going to be 1 because it's not aligned. If we did this, as I said, we'd have to have the padding, which will probably be a page worth because it's on x86-64, which will be 4096 bytes, which we don't really want to be doing just for no reason. So it's fine. And this maybe should look correct. I mean, there's a lot of stuff here because we're trying to read it as if it's a binary file. So let's say it's ELF64. x86-64 like that, and then I think we could do capital M and still keep it as Intel instruction. Layout. Okay, that printed out nothing. Okay, why is that? Help. Let's see. So D just symbols everything. Ah, but there are no sections. We want to... We want to view all of the segments or program header section. Is there a way of doing that? Oh. I don't know. I really don't know. Maybe not. I suppose we know that it's correct anyway. It makes sense. So what we need to do is make sure our executable works. And what we can do is we can say, what does the a.out file look like? Well, it's being read as a 64-bit ELF in LSB, so least significant bit, which should be a little endian. It's x86-64, version 1, it's always version 1. System 5, which is correct, it's statically linked, which is correct, and no section headers. And everything else looks like it should be valid, so if we just do an a.out, it says -11 and it fails. Okay. Why may that be? You wish I could see what this looks like. I suppose it doesn't because you might want to load a specific section, doesn't know what to load. Go run. Have fun. Thanks for stopping by. Glad you enjoyed. So I suppose we can pull out GDB or something. I don't know how this is going to work out, but you know. That's no symbols, aren't there? Suppose that's not going to have too much in, is it? Wow, okay. Let's see if I can find some information on this. Display. Assembly. Unless it is the executable we want, maybe. Yeah, it's TXT. Doesn't seem like anything. Anyway. Yeah, let's have a look. Again, object dump of in here. Visualize jumps. Oh, that's cool. I have to remember that for some time. That'll be very useful. We want the non-option, I'm guessing. I'm disassembling be anymore. Be cool as well, thinking about it, to write out dwarf formatted debug information. That'd be very interesting. Yeah, I don't know if we're going to get much out of it. I think we're just going to have a think a doodle about it. This, if we don't. Oh my, okay, I realize already what's wrong. We're not writing the code. I can't believe I forgot to do that. So let's just write all. Yeah, write all from the code. Then if that fails, as all is. That's part of the, but can we now see? Okay, glad that helped. But we are actually writing out, which is very handy. Separate place, I suppose. Yeah, but we don't really need. Actually, no, because we know this is correct because we've looked at the machine code for this already. So that's there. Oh, maybe. Does that change anything? No, I didn't think it would because 1 and 0 act the same in terms of. Same, double checking. This is incorrect. This should be PHDR. No, this because it's where the offset is. Yeah, this is the one. Right, that's correct. And as offset on X. X. Yeah, I don't see any issues. Magic data version That's the same. I know it read correctly anyway on the file. Odd. That's alright. I don't really know GDB too well. Let's see if we can get something happening with you. See. View. Sure, we can do this, right? But we just SAS. Frame select. Perfect. I just want to disassemble everything. And it's can't. There's no breakpoint. I guess I can specify the break to be the beginning. Let's say break for X. Use the GDB. Yeah, nothing. Okay, file. Yeah, and then note. It's just kind of interesting. Ow. That's graying out. Elf. A. For everything. From memory anyway. To said this already. 42. Okay. It was just me being silly and then doing the offset when I said I don't need to do the offset because I don't want the extra padding. Silly things, silly things. So we are now outputting this program. We are reading it in. We are doing our pushes, doing our pops, our adds, our syscalls and everything, and we are exiting with the correct exit code of 42. If we were to add another 40 and we ran that compiler, and we're not going to do anything else apart from run the compiler on this file and then run the output. We have 84. We are able to compile a file without any kind of backend. Nice. So the achievement has been done, but we want something more interesting than this, preferably. Let's think. If we just put 0 here, this should exit with 0, and we'll all be happy. Sounds good to me. And the reason I'm keeping this dead simple, by the way, other than just because it's nice to have stuff that's dead simple, is if we do go about self-hosting this, we want this to be easily translatable into, you know, the language itself. And the language is not going to be very complicated, hopefully. So simple begets simple, and everyone's happy. Key smoke. Oh, key smokes. What did that take? That took an hour and 40. That was pretty damn quick. Especially since it's mostly just a bunch of boilerplate, right? This is 400, and that was us being not particularly efficient in terms of space. So, yeah, this is working good. Anyway, let's get something implemented such as... okay, let's implement minus as well. just have some more interesting operations. So to add minus in, if we wanted to say, let's do this, since we can use the exit code as a way of outputting stuff, we'll do that. Say 20 and take away 12 from 42, which should leave us with 30, right? We do this now, it will say that there is an invalid token, which will be on minus because we don't know what minus is. Let's add in minus, which is just as simple as copying how plus works. And now we support minus, but we do follow the errors. So first one's 212, 44. Yeah, so this just becomes minus, and this is just sub. That means we need to add in a sub. And this is now missing a sub. Let's do that. And this is going to be the same as add, as far as I know, for the most part, except with switching or sub. Or do we do a subtraction? Subtraction by the f sub. Wrong ones. Integer subtraction with borrow. Ding. Sub. Here we go. Sub. I didn't realize it'd be so far down. I suppose it's mnemonically sorted. I forgot about that. I'm not sorting by opcode. So just 29. Then it looks like it is the same other than 29. It says 30. Okay, we now can subtract. That was very easy to. What do we want to do now? So now that we can add and subtract things, we have, you know, an easy way of doing some kind of arithmetic. It's nice. I think do is implement some kind of equals test. It would make sense to me. So to do that, we want, you know, to be able to check whether 30 is equal to what we have. I'm going to split lines because. So let's implement equal. Do that. We equals here. We equal. See, once you've got boilerplate set up, it's a lot easier to start adding features to things. Obviously, we're going to be doing a bit more complexity in a minute, so we'll have to change up some of the code, but at least for now it's fine. So we'll have an equal, which will just node append, and I'm doing this wrong. So this is, yep, and then we need to handle double A. Yeah. So equal is checking whether two numbers are actually fully equal for all intents. So for that, I believe we need to compare, which is technically a subtraction in disguise. So this is going to be the same as if we were doing a subtraction, just we're not doing a subtraction, we're doing compare. 39, 39, 39. Okay. And then that will set the zero flag, right? And also that will set the well, that will set a few different flags. There's the zero flag, there's the one flag, and other stuff like that, if I remember correctly. All of these flags which are mentioned in here. So compare will modify those flags to do specific things. When we then try and do, like a conditional move, for example, or if we try to do a jump, if zero or jump, not zero, jump greater than, all those sorts of things, it will look at those flags and do things based off of those flags. So what I'll do for now is, if we're checking if something's equal to something, we want to do a C move 0, I suppose, because we just want to push onto the stack, a 0 or 1 as a boolean. So to do the conditional move, we don't want to do this. Right, all in this case, because the opcode is a multi. Like so. And this is a CMOD 0. And then this will be similar, where we have our destination and our source. And it'll only move if the 0 flag is true. So if this is 0, which is true if they are equal, which is what we're checking here, then we want to move 0 into there. So we want to move 0 into a register. So we'll say move. It says move 1 into RDI. Is this? So move 0 into RDI. And to move 0 into RDI, we can XOR, which is very nice and a bit more efficient. So why not? We'll do that. So 31. RDI. It's 3, 1. Don't know if we do or don't need the. I think we do need to say it's 64-bit, probably. So yeah. 1. Yeah. So it's all those. This should XOR hopefully. And then that will be 0, so audio will be 0, and then RSI can become 1, and then we can compare and move this where try and RSI into RDI if those things were equal. And the 0 flag won't be changed because it's set here, and then these don't change the 0 flag, to my knowledge. Yeah, this will move RSI. And then we can put RDI. Really, we probably want to mess around with things in racks, I suppose, but we know that we don't need these anymore at this point. Yeah, okay. Okie smoky. Let's do this in racks. Then RCX and racks, RCX, push. So to change these around. 3, 1, 2, 3. This is same. And we're moving RCX. RCX is second. That means 0, right? 00. So move 1 into there. Then we can 00. That should be correct, hopefully. Because our destination register is on this side and our source one's on this side. Then we just need to put racks. We do here. Believe that's correct. Nothing happened. Is that because it's correct or wrong? Let's find out. So they are equal. And because they're equal, I think that should have pushed one, right? Or moved in one. Because we clear racks and then we move. We conditionally move if 0 RCX into racks. Unless it is the other way around. That's 1. Okay, so maybe it was the other way around. And I'm just misremembering which way around destination source is inside of the RM. So if we say, are you 31, there should be 0. No, that's also 1. Okay. If I move this back though, does this give us 1? No. No. I'm confused. 1, 1, 2 equal. Okay, so this is just why aren't you working? I am okay. What I'm going to do, I'm going to not do this, and I'm going to move 0 into rack very explicitly instead of XORing, just in case the XOR is incorrect. This is, those two are not the same, so it should be 0, and then this should be 1, but it's not. Okay. Why isn't that? This is rack. And C move 0. CM. There we are. So compare. We're doing a. These are the other way around. Do I actually want a 3B? I'm not sure if that matters right in a second, but maybe I want a 3B instead. F. E. If we do this, it's incorrect. So that's 1. They are the same if I do this. That's 0. Okay, so it was wrong. Oh, wait, what? Why is 1 and 2 incorrect? Then I am. Huh. Yeah, so why is. If I did can't do negatives like that. But if I one negative, which is 0, then that's 2, 1. But if I do anything above, no, that's okay. I am thoroughly confused. Yeah, that's 1. Oh wait, what am I doing? These are all correct. That's 0. That's 0. That's 0. And that's 0. Wow, that was a proper brain fart. Alright, so these are all correct. Because 1 is good, 1 means it's true. So yeah, these are both 1. So if I did 20, 20, this is 40, as 40 equals, this should be 1. I said it's 41, 0. Say it's 39, 0. If I take away 1, it's 1, because it's now 39. Ooh. There's probably a nicer way of doing this as well, to be fair, but I'm not doing it the nicer way, I'm just trying to get it working. And yeah, if I do an XOR, let's see if XOR is working, because XOR would be nice. That's 1 still, is that correct? It is. I say it's 39, it's 1 still, which is, I said 49, but it's still incorrect. We're just going to keep it simple then. Only use instructions that we already know about. Why not? Yeah, and now we can go about trying to implement some kind of okay, yeah. So one, we want to do some kind of condition would be nice. How far are we into this? Hour 56. About 10 minutes of just full on brain fart. Good times. To be fair, it's decently late. So if we generate our code, because we're going to need to start backpatching stuff, which means we kind of want access to so I'm thinking, if in our code gen, we instead of taking the writer, own the writer instead, we can, there's a bit more, but we can, I have a solution to perfect. And then that goes away, and now we're only ever doing a modification. Simples. Now we don't have 2 separate functions. So now we can own the writer ourselves. So I'll say code is a standard IO to allocating and then here this will be an out of memory. Then here we don't need to do the thing, so we can do the thing instead. Thinking about it, do we just want to return the writing allocator? Okay, let's backtrack a second here. Let's backtrack a smidgen. Yes. Right. Hopefully I didn't go too far back. What I'm thinking, what I am thinkadoodling is keeping this, but instead of this, we can just take in the allocating writer for the code, right? And in all these cases, so I'll still do this here, right? And then we just pass this bad boy around. So I want to take this by pointery friend. Yeah. I think that'll work fine. So here, I think all of these right dots become Dot writer. They do. So it's writer.writer now. But that's fine. That's fine. That's a small price to make. To pay, I suppose, not make. Well, I am making it, so I suppose I am making a small price. Which means we still do this, but instead of doing this, do that. And then we still catch and that should be fine. That is still compiling, which is correct. Alright, cool. So this way I can still keep track of things in CodeGen. I can say labels or whatever. Standard array list. So, alright. Let's think about how this is going to be laid out for a second. I'm thinking we have some kind of if. Very revolutionary, I know. We have some kind of if, and we can say if one, then do some stuff, and then there's an end. We keep it sort of Lua-like in its syntax. It's familiar. So if one, then do some stuff in here. You know, we might want to one plus one. You know, something. And then we can end. I'm not going to put anything in here for a second. I just want to. Okay. Let's implement. Before we do this, let's implement some kind of. So say 1 plus and then dot. Right. This should just drop the value. We're going to want to add in full stop, but you know, I'm going to be simple about it here. Say dot, we're going to say dot, and we can do dots now. Say then in here when we see a drop. I'm also going to do a bit of this at some point, but I'm not going to do it now. It's fine. Yeah. How do we drop? Well, we drop by just doing a pop. Actually, we don't want to drop by doing a pop. We can do a drop though by incrementing the stack. Sorry, decrementing the stack pointer by the size of a word. So what we can do is we can sub, but instead of doing that kind of sub, we can do a sub with an immediate value. Or we could not do a sub with an immediate value as well. And keep things simpler because we already have working code. But I'll do it like that, why not? So we'll say 1, 5, 5 there means actually we don't want to go there, don't we? What is the numbering in here meaning? I can't remember. Code extension. Okay. Extension. Which means find anything on extension. Or an opcode extension. Okay. So this is just to help distinguish x86 64. On architecture, I tell you. Okay, so that goes in reg, right? Reg, yeah. All right, so this one, so 81. 1, 2. Sub. 2 subtract from press P. 8. Yeah, that should be cool. And media. This is 81. and then the mod RM byte exists for this. We need to select the register, so RSP. So do that first. So reg is, so here we're selecting 7. This. Yeah, 7 would be that. Sorry, my brain just completely had to break down that problem like it was the difficult maths. Maths. B1. Oh no, 7, 5. Because it's 4 plus 1. Then we want to be doing this to RSP, RSP, RSP is 100. 100. Oh. So we segfault, but did we segfault because we don't have an exit? If I say 52, oh, we segfaulted for another reason. Okay. No, I tried hard. Not the other way around, is it? No, because we just said it's in a reg. Yeah. It'd be nice if I could read this. So what I'm going to do, not write any, just write that out, so that I could object dump on it. Hopefully. Oh, but we not oh, different object dump. Binary. There we are. Doing subtractive RSP. No, this looks correct. With 8. Yeah, that's what I asked for. 8 bytes. Yeah. Yeah, so that should be correct. Okay. So what's the problem then? Wait, there's 2 adds, which I didn't add in. What are they from? Is it because this is expecting a 32-bit immediate, even though I'm specifying the Rex prefix? Yes, I think it is. So the Rex prefix doesn't change the immediate on this one, which is interesting. Okay. So let's let this stuff out again and do that. It exited with 42. And then this I'm expecting to fail because there's nothing on the stack other than some gibberish. 1. Okay, this isn't going to fail. 1 is here because there is one argument being passed to the program, which is the program's path. Because of how Linux, at least, I'm not sure about other POSIX systems, handles passing the arguments of a program to the program. If we do nothing, it should still say 1. If I say hello, it's 2, because there's now another argument. If I pop the count, we will see, not quite because it's wrapped by 255, because it's an exit code, but it would print out the, it must be perfectly aligned, fun. It would print out the pointer. If I do another one, this should just start reading gibberish now, but it's not reading gibberish. I'm not sure why that's okay. Interesting. Anyway, it's working, right? If I say 42, 41, it says 41. If I then pop 41, 42, no. Maybe it's not working. Maybe it's not 8, maybe we want, it should be 8 bytes. If I do RSP minus 1. That's not going to be correct. Wait, I'm doing the wrong one, I'm guessing. They did change those around, didn't I? They weren't necessarily supposed to. Yeah, 41. 42. No, actually, no, that's not true because it was using the correct register, wasn't it? So, yeah, no, this has to be the right way around. I'm not sure what's happening. I mean, I could just pop into a random location, obviously. So if we subtract 0, it's still 41. If we subtract 1, we don't need the hello now. Oh, because these will all be zeroed. Till we get to... No, none of this is... If I say subtract like 1,000, I am so very confused. So I want a size of 64 on this, really, just to make sure it's a bit more specific. I am confused. I am very confused. Break contain. Yeah, it should be. Yeah, reg does come first, so it should be the other way around for this. You. That's 40. The second again. Oh, we're not even subtracting. Wait, where? This is weird. So just do a standard. Again. Just to say that we're doing a drop. This should be being right. Yeah, getting a drop. Huh? What the hell is going on here? And it's only changing because I'm moving these around, right? Something very funky is weirdly... No, it's not here at all. It's and. Wait, is it and? It's and here. And. Oh wait, no, this is 5. So yeah, 5 does go in there. Okay, alright. Maybe I'm just stupid this entire... It's late, right? So anyway, that doesn't change the fact that this is... Oh yeah, binary file. Binary file. I like how we change this one thing and it becomes an executable. Yeah, but how does that make sense? That's 40, and that's no longer 41. 2, 4. Is the stack? That's with 10. If I do that, that's just 9. And it's sort of like 9's funky, it prints out fine. Okay. Oh no, wait, it's the stack, it goes the other way around. Wow. I am such a Norman. So we want to add, which is 0, 1, I believe. Oh, we're segfaulting now? Yeah, maybe not. Because it grows downwards, right? So we normally want to take away to... No, yeah, we want to subtract to go back up the stack and add to go down the stack. Error with this one is the error that the... Is this causing? Something else. Not Syscall, sorry. The, oh yeah, because add... I'm using the wrong kind of add. I will add... Zero. Interesting. Subtract is in the same place, just different extension. 230. I am. That sounds more hopeful, to be honest. Let me 1 and 2. That's 1. That's 2. Do some more non-random. In 229, 29. Move 42. Okay. No, this is correct because I'm removing it and then it's the stack. Yeah, this is the address wrapped around however many times with a modulo between 0 and 255. And if we were to do this again, we'd be reading rubbish, which should segfault us, or maybe it will just be 0 initialized. Back to 1 again. Then 42. I'm interested. What's going on here? Oh wait, no, this isn't invalid because we're just reading the elf header now, which is loaded into memory and readable. But if we kept on going enough times, we would eventually, well, we should eventually segfault. Maybe not. Maybe Linux just really wants us to be happy. Or maybe it mapped an entire page. I don't really know. Anyway, don't do this. This is all an aside. But now we can drop things. Good. Right. So let's implement some kind of if. So what we're going to do is we're going to keyword if, keyword then, keyword end. You know, very simple stuff. And keywords static with a tag time. So I'm going to just sort these by case sensitive. There we are. Okay, so we now have just a map of these keywords. And when we do our identifiers, which we don't do yet, so let's do Identifiers can be anything from A to Z. A, Z, or underscore. Put it on this side. We don't have a way of using negative negative integers, yeah, by the way. I think it's pretty funny. I mean, we can make negative integers using a minus, but, you know, -0, but we don't have a dedicated negative integer. The operation, we don't really need an operation for it, I suppose. And then take this. And we also want there to be possible 0 to 9s inside of the integers. So we'll allow that too. Then here, instead of just saying for sure it's that thing, we want to get the slice. So we'll say scanner. Start to scanner cursor. And then tag keyword get, or else it's identifier, because this returns an optional. And that will just give us the keyword tag if it's a keyword. If it's not a keyword, then it's identifier, and we're good to go. We now have a bunch of stuff we need to do. So at 295. In then we're just going to say panic implemented keyword. That way we down here. Boom, 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 boom. Perfect. So we are inside of our high level intermediate representation. Here. So stupid. We need to keep track of like a stack, essentially, of what ends connect and what ends and thens connect to what ifs and so on and so forth. Let's just say there's some kind of stack. I don't really know what to call this, to be honest. Say this has a usize. This won't exist in the end, so we can just deinit this once we're finished. This will be a temporary thing that exists in here. So our conditional stack, whenever we hit an if, some stuff we'll do is we will append a node, if node. So before we do that, we want to get what the node's index is going to be. Index, which will be node's length, and then the conditional stack will have appended to it the node index, or the condition, for the if condition in this case. There's implement if. If is going to be a struct, not sure yet, but this is going to have then size and an end size. And these will be the node indices for where those two things are for the if, which means we need to go back patch it once we finally see the then and the end. So we need to know where these two things are for when we do our code generation. We'll need to backpatch it in there as well, to be fair. Do we actually need information in here? Or is this something that's only needed in the code again? It might be not needed in here. I mean, it's still useful for figuring out whether stuff's connected. Interesting. because we don't know, at least on the x86-64 target, we don't know how much space is in between them, so we'll need to also backpatch there too. I'm not sure we're going to need to do this here other than to check whether it's valid. Let's still do it. I think it'll be useful. Okay. Here we'll append our node index in there, the if that we come across, and then we'll have a conditional stack which will contain the if's location in our nodes list. Then when we hit an then do is we conditional stack dot items dot length not equal to 0, or if it is equal to 0, I should say, want to continue, and we'll push an F, and this will be a this will be a then without if. Let's just be very explicit, I suppose, for the time. This will be a then without if error. A then without if error does a then so this needs to find it, and then it does case, which we know it does exist because we've checked. No, we don't want to pop, sorry, we want to get the last. Yeah, in this case it would be a usize, yes. This is the node. We can say nodes dot if dot then. This is the if node index. To be the node index for then is going to be equal to nodes to length then we can try nodes so on so I don't know. I know we don't need to nodes append. Then is going to be wherever the thing is in here. So when we've seen our then, whatever we actually end up placing in this location will be what's there. So we don't need to declare the then in the operands. That's part of the if. Whew. Okay. Smoky dokie. Then for our end, we're going to similarly do this. Similarly. But this would be an else without if, I suppose. Or not an else, an end without if. And with an if. Found. And matching if. And we're just assuming that if's the only thing that's going to use it for now. Which is why I'm also just asserting essentially that that's the case. Like, really we should check, but it's fine. It's fine. It's fine. Anyway, so we check. Then in this case we get pop this. because it shouldn't be here anymore. We've finished it. It's done. It's gone. We're at the end of that. Then we'll this one and this end index, and that'll be end index here, and that should finish patching that up. Do this. We're missing if in on. So the if should contain the then and the end operands. Okay, to essentially just jump if the stuff in between this and true. So we want to start executing the condition. So that would just be another code gen. Just gonna do another code gen without code. Yeah. What I can do is so what I can construct a new. Yeah. This is probably a terrible way of doing this, but we're doing it with tokens. This is an inner here, a sub here. Then we'll just do the nodes from 0. So from node index, if then errors thing anyway. And we don't want to deallocate in here because this is just a view essentially instead of an allocation in its own right. It doesn't own anything. Okay, I'm feeling this. I thought what we can do is we can just code gen sub here, same writer. Try that. Is this the best way of doing this? Yes, I suppose, because we want to do stuff in between things. So, for our if, it does the code gen up until the condition, then we want to jump if the condition is jump. Sorry, no, yeah, jump false. Yeah, so jump 0, which is a jump. So you probably want 0f. I keep on thinking it's not 0f because 0f is the extension of multi bytes, as far as I remember. This is jump by X number of bytes. If operand size prefix. We don't want to include the operand size prefix, I suppose. I don't know if that means something else. what we'll need to do is we'll need to keep track of how many bytes we've written at various points. So when we see the if here, we keep track of writer written if adder add. And then once we've finished doing this will be and then we want to write these, but I want to fill this with undefined. I think this is going to be 32 bits since we're not using a Rex then in this case. Sure. And then we'll want to come back to this and patch this up. So this will then address, I suppose, will be there. No, not there. Yeah, sorry, I'm trying to think about this. Then happen. I don't even know if we're going to need a then address. This will be jump patch. Yes. I don't know what to call this, so we'll do that. Actually, I suppose this is the. It's going to keep on going back and forth. We'll figure it out eventually. There will also be n at some point. And then in here, we want to create another sub here. Hear ye, you know? And we'll just do this. And then this sub here will be from to the if end to up until but not including. No, up until and including. I think this would, no, not including. Sorry, yeah. This would. Once we've done the code gen for this, we then want to go into at the then address and set. We want to copy. Actually, yeah, that works. Plus size. The value will be the end address, and then it will be on little endian. There is a way of doing that. How about that? And then this doesn't. Hopefully, this is correct. Yeah. Tool. And then we don't need the if, at least for yet. Expected to type that and found that. I had a page where, yes. Like a, as, right. What am I looking for? This, because I expect this to. Maybe. Oh yeah, it's missing those fields. So I just want to set them to. Then the end address is that, but it's that. So this. Yes, the. Oh, and this isn't going to be just set to this, is it? This is going to be in const the end address minus the if address. or then address. Sorry, I think yes, because we want to jump from there relatively, right? So it's the den to the end. So it's the relative amount that we jump. And it says 1, which is, if we say if 1, then 42 end. Ooh. This is going in doobly doobies. Perfect. What you want to see right there. Okay, 3. Yeah. So I think this needs to be +1. It says 42. If 1, 42, and if this is false, then it should be not 42. Okay, something's not right there. Let's go look at the code generating for this. So we're jumping if equal, but we're not actually tracking stuff. Yeah, we need to check if the 0 flag. I think we can do that with a test. 85. Yeah, okay. Right, we need to do the gen, then pop 2 things and test them. Pop 2 things and test them. Okay, so I think test RDI and is it the same as compare? Oh. I think it is roughly the same. It's just faster to perform than a compare. So yeah, we test if they're equal. Well, we test them against each other, and then if they're equal, or if they're 0. So if it's equal to 0, which means which means they all jump. So we don't jump if. Jump 0, jump if they're not. I think it'll be 75. Not. So. Is it 75? No, sorry, 0F85. They're not equal, then we jump. I think. Let's just try it out, I suppose. This is testing execution. So 42. If it's 0, then 42. If it's 1, then it fails. Probably was trying to jump to the wrong place, so maybe it is. Maybe it is. That's what we want. 84. I don't know. Oh, wrong one. Boo. Yeah. Oh. Yeah. So this is 42. If it's 1, it's 42. 0, then it's jumping to an incorrect location, right? Yeah. All right. So let's this now that we're knowing we're jumping around at least. So we're I say yeah, we're pushing 0. Yeah, all right, pushing 0. Popping RSI and RDI. We're testing them. We don't want to do all of this. If we want to RSI and then I, you know what I mean? RDI, sorry. Yeah. So we just want to test our RDI with our RDI to see if it's 0. If it isn't 0, if not 0, so 85, then we want to jump. It's funny because these are the same 85s both ways. If it's not equal, then we jump 24, which is 2 16s, which is 32, then an extra 4, so 36. Yeah, so 36, then that goes to 36 bytes from here. So 6, 7. So that jumps to, which is incorrect. That's pushing forward. That happened because we've code gen. Oh. T0, I do that. And uh, 32. Is that right? Yeah. Why is that 36 though? Because that's 32 and 17. Emulate the conditions to that. $15. Why is that not 15? Why is that 24? Yes, it's 64. I just didn't realize. Oh, it's not. It is 32, yeah. So what? Oh. Well, 32. I'll make sure this is being used by both of them. If I print rel address, then I use rel address. This is incorrect. No, it can't be. It could be incorrect. Actually, what I could do is I could what was splat by 0 or undefined 2 plus psi of I32 times. Then devices. Because I just want to change that one thing. This is 17 and 16, 17. So that's this, which is not where we want to start. Oh no, yeah, 17. I just miscounted it. I didn't start from 0 probably. 17's there. And from here, it should be 32. Actually, wait, no, I could just 15. If it was 15 from here, so we want so 1, 2, 10, 15. This per 2A. That seems right. Why is there so much going on here anyway? We should be moving and pushing. Yeah, popping RDI, testing it, jumping. Then this. Doing this again. That ain't correct. Hmm. This is that. That seems to have cleaned up. Zero interacts. Oh, wait, to clear it. Yeah. Is that correct? Up to RDI, we test RDI, we jump if they're not equal. And in here, we're for some reason cleaning. Then we're pushing that 0. I don't know. Oh. Like we're doing that again for some reason. Yeah, because we're moving 0 in and pushing that again. Might, to be fair, do that. This and that minus that. Is it doing? Alright, what if I don't do stasis? Step. Hello. Thanks for the raid. Cheers. It's all good. thanks anyway, though. People do be sleeping. It's a good day for sleeping, to be fair. Saturday and Sunday. It's also early in the morning for me anyway. So, probably should be sleeping myself. But thanks for the raid. Much appreciated. Did you do anything? Many people did. They are indeed. Do anything fun today? Or just hanging about? I am really broken, confused on why this is doing this. It's really broken. I am confused. I feel like we'd better off just writing assembly at this. But that's besides the so rewriting 0 again. Writing 2.8 again. 2. Not 42. It's 42. Why am I not thinking it's 42? It's way. So why am I that and then doing out? Yeah. Something else. This is just pushing. Oh, you see, this is correct. This is very much correct. Sub client. Okay. This is push media at 0. Wait, what was it for you? Okay, alright, good. So the 2 sub trees are sub here is the correct. Okay. So yeah, then the pop the thing into RDI. So whatever. Test it. It's not too, uh 0, I suppose, in this case. Because if 0 is 0. Ah, Jesus Christ. Fix this compare up. I think this is because this is like an XOR, doesn't it? Anyway, so if we get into the then we push. For some reason, we're pushing 0 again, and then we're pushing 2 again. And then we're popping. We're double dipping for some reason. D. And B stuff. How many things do we? 11. 11 bytes. And that's the way cogen. This is where it's at. So it gets them. Then we do our condition. Surely. So, right. This. That's 10. That's the end of it. That's the condition done. And a jump. Yes. Yeah. Up here. Do that. $11. Some reason. Oh my goodness. Okay. Oh, we want to keep track of what node index size 0. Then instead of doing this, we want to do a index. And here length is also plus equal. I don't know what you would respond to with that because it's good. It's good and I'm happy, but I have no idea what you want to say. And yeah, well, I mean, welcome, hello. I hope you're enjoying. You're still here, so hopefully it's all good. Anyway, we want to grab our node. So what I'm going to do to node. Yeah, and then what we can do. I forgot to skip past all the nodes once we've actually finished. Very important thing to do. We want to set this to be the so that would if and think or maybe n+1. Yep. So we push that and then we pop our RDI once we're at the end and everything like that. And then we should be able to also before we finish overwrite that with the actual value that we want to write. So in this case, 32 doesn't seem right. I don't think he's here, my friend, anymore, unfortunately. But maybe another day if he's back. Yeah, so I still don't know why this is doing 24. It's 24. This should be the relative address. Well, thank you for the follow. I also got the notification via email. So I do have Twitch alerts enabled. They're just enabled via an unexpected mechanism. Anyway. We have a relative address. I don't know why the relative address isn't the expected relative address, unless it is the expected one. I just can't read hexadecimal properly, which is very possible. So let's try and run this output that we generate. It says 42, which is not expected for that, but it's always going to be equal, I think, or not. In this case, it's 1, which it would be if it was false. So maybe we do need this to be and indeed. So we do want this to be the other one. So this would be 84. XNL, is it? Oh. No, I'm not Dutch. So Leonski is taken for obvious reasons. So it's just Leonski backwards. But I mean, it's fun to know that it's with Dutch spelling sounding. I'm not very creative, hence why it's the way around it is. I didn't know what to do. Yeah, so the relative address. Correct. I mean, that makes sense. I know there's a lot of similarity in terms of, obviously, English and Germanic languages and similar languages, just because of history. I mean, I've done a little bit of research into Old English and such. So, have fun. Good night. Enjoy. It's late, so have a good sleep. At least sleep where I'm at, and by the sounds of it, where you're at. So, enjoy. Address is correct. Yes, so switch this up. Okay, so that's 42. 1, it's 2, it's 42. If this is 0, which is false, it's now 1 because it's just what it was before. If I was to say 22, it should be 22. If I say it's 1, it's 42. Okay. We got there eventually. Very fun. Obviously, there's no else clause here or anything, but that's fine. But yeah, we now have conditionals. Symbols. Yeah, that's pretty much it to conditionals, I think. I do have an interesting idea for loops. So, normally you would think, okay, we have a conditional, let's implement some kind of while loop, or maybe just a loop with a break statement or something. What if instead of a loop with a break, we have a loop with a continue, and we do that by having an again keyword, and then instead of having a loop, we just have an again that interacts with the if. So if we wanted to continue looping, right, in this case, so let's say we have some kind of count, right? I want to say if that's equal to 42. And we need some kind of copy. We don't have a copy. That'd be good to have. Way we can do that actually is we can say 42 read up. We'll see if this works. So let's implement some kind of copy. I don't want to do this. Those copies are just going to be a keyword unless I have comma bcopy. Something like that. Enter it. We can just have underscore by itself here. Would be keywords too much. I suppose we could. It's not something do more frequently. I'm trying to think. This will do an underscore. We'll do underscores copy. This is technically a keyword still, though. I do indeed have a GitHub. I don't use it though for anything other than contributions. Same thing with Codeberg, same with SourceHut. But I do, if you want it, it's just believe Leonski. Nope, that's someone else. Leonski J? Leonski J. There you go. Same thing with Codeberg. I think this has got the same name as. Yeah, that's also Leonski J and SourceHut. SourceHut.sh. .org. SourceHut's domain is just SourceHut, isn't SourceH. I'm here. I think I'm J here. Leonski here. The go away challenge. I don't know. Maybe that's not how you search for usernames. I'm not entirely sure. Oh, that's how you search. There. Ski. Yeah, Leonski J like that. Right. This is just gonna be cool. That way right now, I don't think. Just be figured out. Stuff there. If we hit the keyword score, use only GitHub on centralized code base. See, I read that as you only use GitHub and have a humongous monorepo full of all of your code, which I don't think is what you mean, but it's still a funny idea. I mean, yeah, GitHub works for people. I mean, people use what they want to use. The reason I don't really post code on any of the hosts, other than like, some of the more recent issues, is just, one, I'm a bit lazy to do it. It's not that hard to do, I know. I'm joking mostly in that regard. But also, it's just, I find it's not necessary. It ends up being an easier way of having a bunch of random spam and stuff. So the way I do it is normally just old-fashioned, I know, but email me, I'll send you over, a Git bundle. If you want updates, I'll give you the updates. If you want to contribute, you email me with the diffs and the patches, depending on how you want to do that. That's the way I've moved to do it. I still have them, obviously, as I said, because contributions, people use these platforms, so I have accounts for these platforms to interact with other code bases. I'm fine with doing that. But for my own personal projects, I don't have a massive community of people who look at stuff anyway, so it doesn't really matter. And once I have my website up, it'll be easy to grab, to get bundles for or stuff. So, and the amount of people who generally want to contribute to a project versus interacting with it is a pretty low ratio. So, I mean, it works. It works. It's great. If you want to have a GitHub or other, I think they're called Git forges. You want to have another forge, just so it's easy to interact with and people feel like it's a bit easier to communicate or whatnot. People don't generally like communicating directly with others at this day and age. Anyway, so for underscore, what I want to do is I want to. There's probably a better way of doing. Like going here. I want to. Node. I never even checked. I know my desktop audio is muted, alright, because that would all be. Going up. That's why. So in here, if we're copying things, it's going to do any pop axes? No. The easiest way I can think of doing this is 58, which I think is pop rack. Yeah, 58. Doing a pop racks, so pop the top of the stack into racks and then push racks twice. That should just copy our value for us. So that's 42. Then if I drop this, it should still be 42. Then if I drop this again, it'll be 1. Okay, cool. So that's working. So yeah, if we had an if 0, 1 equals, then 42. So that says 1, which is correct. Then if 0 equals 0, 42. I'm just double checking these work because I don't want to have broken things. Yeah, that's correct. If 1 equals 1. Hey, perfect. Alright. Get rid of these bugs now. Done. Perfect. Okay, so now that we can copy things as well, which is useful, talk about this again. So if we had an if we have a count, say 0, and we want to say if that's equal to 1, so what I'll do is I'll say copy that and check if it's equal to 1, then do something, and if it's not, well really we want a not equals, I suppose. So we could do like a while. Okay, let's implement a not equals somehow. Yeah. Okay. We don't really need a not equals. We just need a not, which doesn't quite work. No, not easily. Not easily in terms of an arithmetic not. Right, let's implement a not equals. If we see exclamation mark, we continue into I think it's exclamation like that, right? You get rid of the I. Yeah, I'm just double checking my own spelling. I can spell. Sometimes I'm not. Yeah, if we hit an exclamation, we'll move into the exclamation state. And then when in the exclamation state, check to see whether we hit an equals. If we do, then we'll have an exclamation equals, which will be this will just exclamation equals like so. This is after dot. We'll just keep it somewhat ordered. Helps when you're trying to read code. Yeah, so if we hit this state exclamation equals as continue into the invalid. So we don't understand it otherwise. No, have that. That should cause errors. Yeah. But yeah, it's just reversed without the J. The J is really only there as a placeholder thing because, you know, sometimes you just need a placeholder. It's also a very commonly used nickname. Either I need a new name, a new nickname, or I need to do something to make it more unique. I might just go with the Isknoel. Ixnoel. I don't really know how you pronounce that, to be honest. I'd have to figure that out. It doesn't really matter, I suppose. But, you know, I could do that. That'd be a way of doing things. So, neck. Not more. Yeah, to implement, which should be decently simple. Should be able to just copy paste this code and change the opcode from a not from the compare from the this to the move O is 0F. Oh, no, it's overflow. This one seems obviously. I want not 0. 0, which is 45. I do kind of. Most of my game dev experience is more so on the planning and solutions to problem spaces. My friend is developing a thing called Airwave, which I've helped develop. I think it's .cc. Yeah. Which I've helped develop bits and bobs for, but he's currently going for a big old rewrite from it being a web-based thing into Bevy. But yeah, I did help do some programming work for this. I do more so though, as I said, ideas, solutions to problems and stuff, and talking to him about that sort of stuff. But yeah, this is pretty much my foray into game dev. I've done other smaller projects here and there as well, but nothing like game, like AAA or even indie-esque. So, hopefully that answers your question in some regard. Not equal. Say 0, then 40. That's, say it's not equals, then that's 42, good. Then once these become equal, then I end up with gibberish. Somehow. It should be 1. Oh no, okay. It was just because I had gibberish. Yeah, idea 0, say if, because it's concatenative and stack based. So if we want to do some kind of addition, say 20 plus 22, we'll do the addition here as a reverse post notation. Then this would end up as 42. I'm using the exit code, by the way, on this right side for what it ends up being, just so I can test things easy without having to implement some kind of writing functionality. So in this case, yeah, stack. So here I'm just trying to figure out how I want loops to work. So I'm thinking of having them being if based, and then with an again keyword. So the way it would work is I can say, you know, well, copy this thing is not equal to 4, right? Then I can add on to it, add 1 onto that, and then if, actually no, this case would be if, then this would be this. If it's not 4, then go again. Although this isn't going to work because this again is attached to this if, not this if. So I'm not really sure. So this is the point of having a loop. So what I could do is I could implement a loop and then have a gain on the loop, and then you just have to make the ifs yourself for things. It's very possible. Yeah, maybe I'll do that. So I need to keep track of end as a loop, or a then, or an if. So. To be fair, let me check the time. It's currently 2:30 in the morning. It might be time to go to bed. Oh, do I get loops implemented? I mean, I've done a decent amount for. God, it's 3.5 hours. Never mind. It was a lot less time than that. Okay. I think I'll call this one here, and I'll get loops implemented in another stream. Good to me. Hopefully, a bit of an earlier stream than this one. Anyway, I think that will be all. But it's been nice talking to the chat. Thanks everybody for showing up, who has showed up. Right? And I'll see you tomorrow, maybe, or the day after, or whenever the next stream is. Have fun. The VOD will be up on YouTube. I have it going here. This don't seem like long enough, but yeah, I'll find out. I'll make sure it is. Yeah, enjoy.